Hello, this is Mr. Collier, and today we're looking at the converse, the inverse, and the contrapositive of conditional statements. Um, so if you have a conditional statement like P implies Q, then the converse is Q implies P. Um, so if we look at this example, P implies Q, so this is if Tamika lives in Montana, then she lives in the United States. Oops. So that's a conditional statement. And if we just reverse the order of the P and the Q, we have the converse. So this is the converse, and it's Q implies P. So if you look at the converse of the statement above, it is definitely false. If Tamika lives in the United States, she doesn't necessarily live in Montana. But the original statement, the original implication is true. If Tamika lives in Montana, then she lives in the United States. So that one's true. Alright, so what can you conclude about a conditional as converse? You can say they are not logically equivalent. Alright, just because one is true doesn't mean the other one's going to be true. One could be true and the other one could be false. So they're not saying the same thing. If Lily does her homework, then she will do well on the test. So the converse is the opposite of that. If Lily does well on her test, she did her homework. That's the converse of that. Okay, let's take a look at the truth table. So this is the truth table of Q implies P. So remember now, let me just make another truth table real quick and remind you about the truth table for P implies Q. So P implies Q, remember that is only false when P is true and Q is false. Okay, and the rest of the time it is true. So if you have Q implies P, there's only going to be one instance where it's false. Okay, and that's when Q is true and P is false. Okay, so it's the other way around. So if Q is true and P is false, then the statement Q implies P is false, and the other ones are going to be true. Compare the truth values for the conditional and its converse. So this is the converse. The conditional is right here. So they are not the same, or they are not logically equivalent. Okay. Next, we're going to look at the inverse of a conditional. The inverse of a conditional statement results from reading both the hypothesis, negating both the hypothesis and the conclusion. So the conditional, if the conditional is P implies Q, then the inverse is not P implies not Q. Alright, so write the inverse of the conditional statements below. So if Tamika lives in Montana, then she lives in the States. So you just need to put a not into both statements, and you have the inverse. Is the inverse of the statement above true? If Tamika doesn't live in Montana, then she does not live in the United States. That is false, right? So what can you conclude about a conditional statement and its inverse? Okay, so you can tell just by that they're not going to be equivalent. They're not saying the same thing. Alright, so if you look at this example, the San Francisco Giants win all their games, then they will win the World Series. So you basically just need to rewrite the entire statement. If the San Francisco Giants don't win all their games, then they won't win the World Series. Okay, so you just need to stick a not into the statement. So So the truth table, that's how we construct the truth table. We start off with not P, not Q, and then we can look at the conditional. So if we have not P, that's just the opposite of P, so that's going to be false, false, true, true. And here we're going to have false, true, false, true. Okay, so not P implies Q. Remember, that's only false if not P is true and not Q is false. So it's going to be this one right here. It's the only place where that's going to be false, and the rest is going to be true. So we've got these truth values for not P implies Q. Or not, sorry, not P implies not Q, the inverse statement. Compare the truth values of the conditional and its inverse. So the conditional, remember, is if the conditional is P implies Q, it's true, false, true, true. So they are not logically equivalent. All right, last one, the contrapositive of a conditional statement. You interchange the hypothesis and the conclusion, and you also negate it. So it's going to be, if you have P implies Q, it's going to be not Q implies not P. Not Q implies not P. So if Tamika lives in Montana, then she lives in the United States. That's the P implies Q. So not Q is she doesn't live in the United States, then she doesn't live in Montana, which in this case is actually true. If she doesn't live in the United States, then she doesn't live in Montana, so that's true. That's true. What can you conclude about conditional? And it's contrapositive. You could say that they, well, until we look at the, we'll look at the truth table in a second and figure out that they are logically equivalent. So I guess we could say that they're logically equivalent here based on this, or to suggest that they're logically equivalent. Okay, so we construct the contrapositive here by saying, well, this is Q over here, so not Q is if food is not salty, then you didn't put salt on your food. Which makes sense, right? Okay, so if P implies Q is true, then the contrapositive is always true. If P implies Q is false, then the contrapositive is false. So the contrapositive and the conditional are, so if you have like, yeah, P implies Q and not Q implies not P, those are logically equivalent. Alright, so look at the truth table. So we can get not Q here is the opposite of Q, so that's false, true, false, true. Not P is false, false, true, true. And not Q implies P. Remember, this is only true if this is if this one is true and the other one is false. So it's only false in that case, and the rest of the time is true. So we have T, F, T, T. So remember, the original or the conditional is P implies Q, and for P implies Q you also get T, F, T, T. So P implies Q and not Q implies not P are logically equivalent. Compare the truth values for the conditional and the contrapositive, so they're logically equivalent. We just talked about that. So we have the four different forms of implications here now. We have the conditional and the contrapositive and the converse and the inverse. So the conditional and the contrapositive are actually logically equivalent, and the converse and the inverse are also logically equivalent. Okay, write the converse, inverse, and contrapositive of each statement below. Determine whether the original statement and each new statement are true or false. If a triangle is equilateral, then the triangle is isosceles. The converse is going to be, well, let's write out here, Q implies P. The inverse is not P implies not Q. Contrapositive is not Q implies not P. So the converse is, we switch them around, if a triangle is isosceles, then it is equilateral. Okay, so that's the converse. The inverse is not P implies not Q. So if a triangle is not equilateral, then it is not isosceles. And the last one, contrapositive, not Q. So if a triangle is not isosceles, then it is not equilateral. Okay, so we got all the statements written out. It says determine whether the original statement and each new statement is true or false. If a triangle is equilateral, then it is isosceles. So that's true. Okay, equilateral means three sides are equal. Isosceles triangle means two sides are equal, so that is true. If a triangle is isosceles and is equilateral, that's false. You can have an isosceles triangle that's not equilateral. If a triangle is not equilateral, then it is not isosceles. That is false. Right? Just because it's not equilateral doesn't mean it's not isosceles. It could be isosceles. And the contrapositive, if a triangle is not isosceles, then it is not equilateral, is true. That makes sense, right? And notice that the original statement is true, and the contrapositive is true, and the converse is false, and the inverse is false. That's always going to be the case because the converse and the inverse are logically equivalent, and the original implication and the contrapositive are logically equivalent.